All right, this is going on page 35 when we are done. So the last couple of days, we've talked about all things rational functions, right? Just kind of went through the gauntlet of everything. And then these notes are going to hopefully, so because somebody said today, this is one of the easiest things we did. I said, yes, but it probably wouldn't have been as easy if we hadn't done what we did the last 2 days, right? So we already kind of know a lot of this information. We're just tweaking some of the notation and some of the wording with some things, but we kind of already know most of this, right? We're just kind of putting things together. So we are looking at rational functions and end behavior, okay? And so rational functions, we can talk about end behavior. We can also talk about middle behavior. Your middle behavior is more your vertical asymptotes and your holes. So although we are going to talk about those again, that's not what we're doing today, okay? So what we know, and we've already said this, but we didn't actually write it down, is a rational function is a quotient. Quotient means we're dividing, or a fraction, or a ratio. That's the root word of rational, right? It's just a ratio of two functions. Okay, so we have rational function y equals f of x over g of x, where they're both polynomials. G of x is not equal to 0. And this also could be written as like h of x equals f of x over g of x, something like that. So here are 3 examples of what look like rational functions. Shouldn't be any big surprise. Notice that we have 2 over x plus 3 as an example, but x plus 3 over 2, not a rational function, right? So you don't have to have variables in the numerator and denominator. You can, but you at least have to have them in the denominator. Otherwise, we could just write it as a fraction out front, right? So that's what makes a rational function a rational function. Okay, so I said we're not talking about our vertical asymptotes or our holes, but our end behavior all revolves around our horizontal asymptotes, because those are the ones that go all the way out to the infinities, go out to the ends, right? So the end behavior of a rational function is determined by the leading terms of the numerator and denominator. So here, this could be a much longer function. I mean, this could be representing this function right here, but we're only worried about, like it's talking about just the leading terms, like just those two. That's what that is right there. So a and b are the leading coefficients of those terms. The n and the d are the degree. So numerator and denominator. That's why there are those 2 variables there. So we have case 1, case 2, and case 3. So case 1 says that the leading terms have the same degree, or n is equal to d. Numerator is equal to denominator. Okay, so when they have the same degree, that's what we also know as tied in degree. This is a more official way to say all of this stuff and see it with variables. So I want to make sure you understand that everything that's written right here, which might look confusing to some of you, is stuff you already know. We just have to make sure we can interpret it correctly. So then it has a horizontal asymptote at y equals a over b, because that is the ratio of the leading coefficients. And that's something we know about them being tied in degree, right? Case 2, if the denominator dominates, so the degree of the numerator is less than the degree of the denominator, or the degree of the denominator is greater, if that's true, then that makes this bottom heavy. And we know that if it's bottom heavy, we have a horizontal asymptote at y equals 0. Right? Then if the numerator dominates, so n is greater than d, that's what makes it top heavy. And with top heavy, for horizontal asymptote, we know that we don't have one, right? Which opens the door for a slant asymptote, but in general, the end behavior of the polynomial is this right here. And all that is the ratio of the leading terms, not the leading coefficients like it was here, but the actual leading terms. Because if I was to simplify this, that's just a over b, and then you just subtract the exponents and you get this right here. And that gives me the end behavior. It does not give me the asymptote, but it gives me the end behavior of the polynomial. And I will clarify that a little bit more as we go. Then it goes on to say, if the degree of the numerator is exactly 1 more than the degree of the denominator, then we have a slant or oblique asymptote. Okay? So this is generalized because it's not always just 1 more. But then this is more specific and really the only one we're looking at right now. Okay? And I will kind of clarify why that all looks a little bit different as we go through this. Okay? Everybody good so far? Stuff we pretty much already know, right? Okay. So let's look at these examples. It says to determine if the following rational functions have a horizontal asymptote, slant asymptote, or neither. Notice it doesn't say none. It just would mean neither, because maybe it's parabolic or something else. If we have a horizontal or slant, we want to write the equation of the asymptote. Okay, so when I look at, all I'm looking at is the two leading terms here. Okay? Is this top heavy, bottom heavy, or tied in degree? Tied in degree. So that means the numerator degree equals the denominator degree. Okay, we'll write it in terms of what they have right there. So do I have a horizontal asymptote then? Yes or no? Yes, I have a horizontal asymptote. And what is it? 3 over 5. So my answer is 3 over 5. Y'all agree with that? We all going to be wrong? Because we'd all be wrong. Y equals, yes, very good. It is a line. You have to write it as an equation of a line. Makes sense? Yes? Okay. So then let's look at B. I've got 2x and x squared. Top heavy, bottom heavy, or tied in degree? Bottom heavy. So if it's bottom heavy, that means the numerator degree less than the denominator degree, right? The alligator eats the bigger one, right? Okay, so then do I have a horizontal asymptote? Yes, I have a horizontal asymptote, and it is where? Y equals 0. Very good. Everybody good with all that? All right, so let's look at C. I look at these two here. Top heavy, bottom heavy, or tied in degree? Top. So the numerator greater than denominator as far as degree is concerned. Not only that, but n is equal to the denominator degree plus 1. Make sense? And this does not really mean, doesn't mean the numerator, it's the degrees of those. So that means the numerator is 1 greater than the denominator, so will I have a slant asymptote? Yes, and then I'm supposed to find it. What do I do to find it? How do I find a slant asymptote? What do we do to figure out what the equation actually is? Okay, we could simplify it. And so just because we don't, do what? I have to divide. And I could simplify first. That does help to simplify first. So since we don't have a ton of room, let's just talk through the simplifying. If I did that, I could, in the numerator, I could factor out a 2. That leaves me with x squared minus 2. Is that going to cancel anything out in the denominator? No. So since we don't have room for that, yes, I would absolutely want to try and reduce it first because that would help. But then I'm going to have to divide. Can I use synthetic division here? No. Okay, so we're going to use long division. So 5x plus 9 is going to divide into 2x squared minus 4. Yes? Sure about that? Plus 0x. Good. Plus 0x minus 4. Okay. So I take my first term, 2x squared divided by 5x. What is that going to give me? 2 over 5 times x. Yes, so it gives me 2/5 x, right? I know you don't like it, but it's really not that hard, right? Just 2/5 x, because if you put those over each other, boom, that's what you get, right? So then our next step is to multiply it back. So 2/5 x times 5x gives me 2x squared, because if it didn't, then I didn't divide it correctly, right? So then what's 2/5 x times 9? 18 over 5. So this is plus 18 over 5 times x, okay? Don't let your brain shut down just because there's a fraction in there, all right? Because it's not going to be nearly as bad as you're thinking it is right now. So then these two are going to zero out. So 0 minus 18/5 x is negative 18/5 x. See how hard that was? And then I bring down my 4, negative 4. Okay, so a negative 18/5 x divided by 5x. So first of all, the x's will cancel out, right? So I'm only worried about the numbers. When you're dividing fractions, so if I divide by 2, isn't it the same as multiplying by 1/2? Right? So if I divide by 5, it's the same as multiplying by what? 1/5, right? That makes sense? So basically, if I'm going to take negative 18 over 5 and divide it by 5, that's the same as taking negative 18 over 5 and multiplying it by 1/5. If I multiply it by 1/5, what do I get? 18 over 25. So I get negative 18, and now I'm blended in with my little things here, 18/5. Now, do I need to go any farther? No, because I don't care about the remainder, right? So I don't have to worry about multiplying it back and what does all that do? Nobody cares. It's fine. We're done. And so my slant asymptote then is at y equals 2/5 x minus 18/5. Ask me a question. It is 18 over 25. Yes, it is. Thank you very much. I think I said that and then I had to erase something. There we go. It is 18 over 25. It is not 18 over 5 because that's what y'all told me. That's what we said, and then I wrote the wrong thing. Thank you. Anything else? Okay. We good? Questions? Okay. Not pretty, but doable, right? Okay, so let's look at this next one. Leading terms. I have n, numerator, denominator. What goes in between them? Equals, right? The numerator degree is equal to the denominator degree. So do I have a horizontal asymptote? Yes. And where is it? Which is 1/2. Good. Look at y'all using fractions, not freaking out. Okay. So for E, I have numerator and denominator. What sign goes in between them? Less than, yeah. The numerator degree is less than the denominator degree, right? Which means that it's bottom heavy. Yes? Do I have a horizontal asymptote? Yes. Y equals 0. Very good. Okay. So then, in numerator, denominator, what sign goes in between them? Less than. Does it matter that there's a negative sign out front? No, it does not. Where's my horizontal asymptote? Y equals 0. Very good. All right. Any questions at all? We all good? Pretty much the same thing we had already done. Yes? Okay. All right. So now we are being asked to write limit statements to describe the end behavior of the polynomials. The only thing I have to write is the limit statements. However, the limits and the end behavior is all related to the horizontal asymptotes. So it's not asking me where it is, what the asymptote is, but it's something I still have to know and I have to think about, okay? So on A, if I look at my two leading terms here, top heavy, bottom heavy, or tied in degree? Tied in degree. So I have a horizontal asymptote at y equals what? 1/3. So my end behavior limit statements, let's go ahead and get them started. For the left, way out at the ends, I am finding the limit as x approaches negative infinity, because that's what I get to when I move to the left, of f of x. You always have to have an argument there. And then the right-hand end behavior would be the limit as x approaches infinity of f of x. So let's talk about this, and I'm going to use the pictures we looked at the other day instead of me trying to draw something where you can make sense of it. So let's use this function. I'm not saying that that's the same function. Could be, but again, we don't really care about the middle behavior, right? So who knows what's going on in the middle? Not worried about that right now. We're talking end behavior. So what I do know about the function we're actually working with is that I have a horizontal asymptote at y equals 1/3, right? So we're going to pretend, because there's nothing drawn on here, that this, I'm going to use a different color so you can see it. This is at 1/3, okay? So now I have a horizontal asymptote at 1/3, right? Regardless of what's going on in the middle, way out at negative infinity, what y value am I approaching? 1/3, right? Am I ever going to make it to 1/3? No. And again, I could cross it and come back, but when we're talking way out at the end, I'm just approaching 1/3, right? And so way out at infinity over here, what y value am I approaching? 1/3. This one's approaching from the top, this one's approaching from the bottom. I don't even know if this looks anything remotely like the function we're talking about, but it doesn't matter. It's not asking us even if it's from the top or the bottom. Either way, I'm approaching 1/3. Make sense? So if you have a horizontal asymptote, that tells you your end behavior. So the limit as x approaches negative infinity of f of x has to be 1/3. And the limit as we approach infinity has to be 1/3. Okay? Make sense? We good on that? So we're just taking what we know about asymptotes and adding to it what we know about limit statements. Okay? So let's look at B. I've got these two that I'm looking at. Top heavy, bottom heavy, or tied in degree? Bottom heavy. So my asymptote is at y equals what? 0. So I can write the limit as x approaches negative infinity of g of x equals, and the limit as x approaches infinity of g of x equals. All right, so I have a horizontal asymptote at y equals 0. As x approaches negative infinity, what is y approaching? 0. As x approaches infinity, what is y approaching? 0. Easy enough? If you understand horizontal asymptotes, you can do this. Okay? All right, so then let's look at C. Here are my leading terms. Okay? And is it top heavy, bottom heavy, or tied in degree? Top heavy. So do I have a horizontal asymptote? No. I have a slant asymptote, right? Now, instead of actually finding the slant asymptote, we're going to go back and revisit what this said over here, which may not have made a whole lot of sense to you at the moment. But when it's top heavy right here, the result is not saying that this gives you the slant asymptote. It's saying that the end behavior is modeled by this. Right now, nobody's asking me what is the slant asymptote. They are asking me what is the end behavior, right? So what I can do then is just, again, take the ratio of the leading terms and get a function. So y equals, so negative 3 over 1 is negative 3. X to the 4th over 3 is what? I'm sorry, x to the 4th over x cubed is what? X. Okay? Now, let me be very clear on something. I'm not reducing my function this way. And if we weren't talking about this, that's not how I get to reduce the function, right? We all understand that, yes? Because I don't want you to start thinking I'm doing magic math. I'm not actually reducing the whole function. I'm just looking at those leading terms to get what my end behavior is. This models my end behavior. So this is an equation of a line. Do we agree with that? Okay. It's an equation of a line. And the slope is negative, and this particular line goes through 0, so it would look something like that. You with me on that? So now if I really continued to divide all this out, if I really did my long division, let's think about what we do. So with long division, it would be this divided by this, right? And the first thing we do is take this first term and divide it by this first term. Isn't that what we get? So that really is the first part of my answer, right? I just don't have the rest of it. So that means that I have some other y-intercept other than 0, okay? Rewind back to geometry and algebra 1. Parallel lines have the same slope and a different y-intercept, right? So what I do know is that my slant asymptote is parallel to this line right here. I don't know what it is, and I really don't care exactly what it is, but it's parallel to it. Maybe it's above it, maybe it's below it, I don't know. But either way, would the end behavior be the same? It would, right? I'm still going to the specific different way. So let's look at one of those. We find one that has the... Okay, so this orange line has a negative slope, right? And it would be parallel, let's just pretend like the slope is negative 3. So this would be parallel to that same line, negative 3x plus something, whatever. But then the end behavior of the function is the same as the end behavior of the line. You see how that works? So if you can just get to this right here and understand that that is not your slant asymptote, but it is parallel to it, then you can draw yourself a line like this, and then you can come up with the end behavior. So let's write them down. The limit as x approaches negative infinity of h of x, you always have to have an argument. You can't just say the limit equals. So as x gets smaller and smaller and smaller, what are the y values approaching? What are they approaching? Infinity. Yes. And for the right-hand side, the limit as x approaches infinity of h of x. So as x gets bigger and bigger and bigger, what's y approaching? Negative infinity. Okay. Do you see how that works? Yes, exactly. Very good. I heard. She said, as x increases without bound, y decreases without bound. And that's great. Those words need to be in your head. Good job. All right. Any questions about any of this? All right. So I want you to understand how to do this simply, right? But also understand if I need the actual slant asymptote, I'd have to actually do all of the division, okay? And I will repeat this once I give you the worksheet, but I'm just going to tell you. On the first part of the assignment, the instructions are the same as this, okay? And I want you to do that for the horizontals. For the slant asymptotes that you come up with, you do not have to give me all the division. For the slant asymptotes, I'm changing the directions to say, give me the equation that the slant asymptote would be parallel to, like we just did. So here, and so we did all of this, right? Which I know freaked you out. That's why I thought maybe you'd pay a little bit more attention to where we wouldn't have to do that. Because what I know is, this is my slant asymptote, right? But if I just did this ratio right here, I get y equals 2/5 x. And I know that this is parallel to that. You see how this goes through 0 and then this is parallel to it? This is all you really have to give me on the assignment, because some of them don't divide very nicely. And that's, we're not trying to get you into like crazy stuff. I just want you to understand the concept. Okay? All right, so let's finish this up then. All right, so D and E give us functions. They give us graphs, but they didn't name them. So we're going to name them. This one, since it's D, we'll call it D of x and E of x. Because we can call them whatever we want. But we want to have something. Okay, so I have no idea what the actual equation is for this function. We could figure it out, but it really doesn't matter right now. My left-hand in behavior, limit as x approaches negative infinity, d of x equals, and we'll go ahead and write limit as x approaches infinity, d of x equals. All right, so as x decreases without bound, what does y approach? 2. And as x increases without bound, what does y approach? 2. Easy enough? For most of the rational functions, they will end up being the same, but not everything is a rational function. Right now, that's what we're dealing with, but definitely look at it and make sure that you know what's going on with that, okay? All right, so then you go ahead and do E, write the whole thing, just so I can make sure you get the notation. I'll write it too, and then we can compare. So this is what you should have. Make sure your notation is correct. Make sure you didn't leave off the E of x. Make sure you're sitting up and paying attention. Okay, we all good? Any questions? Turn your sound off. Okay, so let's talk about slant asymptotes. We've kind of already talked about this stuff and we discussed it, but this is where it's kind of written formally, and we'll go back and look at it, make sure we understand it. So we know that if the degree of the numerator is exactly 1 greater than the degree of the denominator, then it will have a slant asymptote that is parallel to the ratio of the leading terms. That's what I just talked about, okay? So it does have a slant asymptote if you divide, but if you only take the ratio of the leading terms right here, then we know it will be parallel to that line, right? Because this ends up being that, because this would be actually be A over B times X to the n minus that right there. That's what it said on the front. Well, if it's exactly one more, then no matter what these two numbers are, when you subtract them, you get 1, and that's why you get this right here. Okay? Does that make sense to you? So again, not saying it's our slant asymptote, but it's parallel to it. So let's look at what this says down here. It says, which of the following rational functions has a slant asymptote parallel to this line? The first time I worked through this, I was like, I didn't realize it was saying parallel, and I was like, it cannot be the same. It doesn't make any sense, but parallel. So make sure you're reading your questions, unlike what I was doing. So when I look at the two leading terms right here, what kind of asymptote would I have? Horizontal. Where? 1 over 2. So this would give me a y equals 1/2, right? Is that parallel to 1/2 x? No, because that's a horizontal line, right? So I know it's not 1. Can't be that one. Then this one right here, what kind of asymptote do I have? Top heavy, bottom heavy, or tied in degree? Bottom heavy, so I have one at y equals 0. Okay, so oops. So I don't like this one either. So then I know it can't be 1 and 2 only because it wasn't 1 or 2. So then I look at this one. Top heavy, bottom heavy, or tied in degree? Top heavy. By how many? 1. It's top heavy by 1, so do I have a slant asymptote? Yes, and when I take the ratio there, I get y equals what? 1/2 x, yes? Is this my slant asymptote? No, because I know I didn't really divide legally, right? But it is parallel to this, so I like number 3, right? Then we look at 4. Top heavy, bottom heavy, or tied in degree? Top heavy. By how many? 2. So do I have a slant asymptote? No. This is where you would get your parabolic asymptote. So I don't like 4, so it's not 3 and 4 only, so it's C. Okay? What questions do you have? You good? All righty.